Hey everyone, and welcome to the video. Today we will be looking at a PIC-to-PIC 8-bit parallel transfer example. So, we've got two PIC18F45K20s, we've got the transmitter and the receiver. So essentially this will be outputting on 8 lines, ones or zeros, transmitting via port D. Then the receiver PIC will receive via port B, and then it will output those received values on this bar graph display using port C. So both microcontrollers have got 20 MHz crystals, two 18 picofarad capacitors. On pin RA6 and 7. On pin RE3, we've got the master clear pin pulled up to VDD. So this entire circuit is powered by 3.3 volts. On the receiver microcontroller, we've got a green bar graph LED connected via 15 ohm resistor network. And that's it for the schematic. So now we will have to generate two projects, one for the transmitter, one for the receiver. So firstly, I'll show you how to make the first project for the transmitter. So we go to our MPLabX IDE development environment, go to File, New Project, Mark Chip Embedded, Application Projects, click Next. Type in the device name, PIC18F45K20, click Next. We're using XC8 version 2.46, which is the compiler. I'll call this T6A, T6T, so task 6 transmitter. Make sure you know where you save your project. Also make sure you've got this checked, set as main project, open MCC on finish. Finally click finish. So select MCC classic content, click here, click next. So we need to set up our external clock. So we go to the system module, oscillator select, HS oscillator, which stands for high speed oscillator. System clock select as FOSC, external clock 20 MHz. That's all you need to do in this tab. The last modification you need to make is in the pin manager grid view. So we need to set our ports as outputs. So we're using port D this time. So we go to the pin module, GPIO output, and go to port D, and click all the locks, like so. And that is all you need to do for this microcontroller, other than click generate. Yep. So that's done. So we can exit out of that. So now I'll show you how to generate the configuration for the receiver. So similar as before, File, New Project, PIC Embedded, Application Project, PIC18F45K20, click Next, XC8 version 2.46, project name, task 6 receiver, I guess. Make sure you know where you save it. Make sure these are checked. Says main project, open MCC on finish, and then click finish. So we want to go for the MCC classic content. Click here, click next. So this configuration has a few more steps. Okay, so firstly we'll set the system module. We want to set up the external crystal. So oscillator select, high speed oscillator, system clock select FOSC, external clock 20 MHz. That's fine. So now we go to our pin manager grid view, and we need to first set all of port B as an input. So go pin module, GPIO output, port B column, and select the top locks like this. And then we also need to set all of port C as an output. So we go back, port C, and select the lower locks. And finally, just click generate. There you go, generation complete. One thing to make a note of as you're working on two projects, whichever project you're working on, always make sure that you set it as the main project. So for example, if I want to return back to the transmitter code, right click and select set as main project. Then when I compile the code later on, it will actually build and compile this one. If you want to go back to this one, just right click on the project and select set as main project. So always make sure you have this selected on whichever project you are compiling. Okay, so now that we've set up the project for both microcontrollers, let's go through the code for the transmitter one. So for the transmitter, we've got our main function here. We're initializing the system, so setting the port D as output. We're then loading lat D with 0x55. So similar to the previous video, we are loading 0x55, then we're complementing it here and loading it back into lat D. And then we've got a short delay function so we can see the transition. And that's all for the transmitter code. For the receiver code, similar, we've got the main function, initializing system, but in this case, we are reading the status of port B and then loading that value directly into lat C. And that's simple as it gets. So now if we run the simulation, and as you can see, we are getting our output here. So as this is complementing either 0x55 or 0x8A, this is also providing the delay value. So all this is doing is reading that value and now putting it at the same time on port C. Well, that's it for today's video. I hope you found it useful. Source code and files can be found down below. Till the next time, goodbye.